Okay, so the last part of this, okay, remember, don't make this harder than what it is. If you don't like saying infinity and you just want to tell me up, that's fine. If you're like, Thrasher, what does f of x mean? Don't forget f of x means the same as y. Okay, the y values are going to infinity, the y value, what does that mean? That means they're going up. Y values go up and down, x values go left and right. So when x goes to positive infinity, this is just a big fancy way for saying right side. When x goes to negative infinity, that means left side. What are the y values doing? On the right side, they're going up. And on the left side, they're also going up. Look at the picture of your graph. I don't care about this middle stuff. Don't care. Okay? Now, when you look at your graphs, okay, so for this last part of this video, when you look at your graphs, you got all those other examples on there. If you want to see anything, let me know. Okay? But there's a way you can tell what this does before we do any of this. So kids, when I look at number 5, I already know the answers. I don't even have to look at a picture of a graph because I know the degree is 2. So this is a U-shape. Instantly, I know it's a U-shape. When the number is negative out front, if you remember your leading coefficient and you remember your transformations, when this number was negative out front, what did it do to your U-shape? It flipped it over. So something that has an x squared with a negative out front flips the graph over. What do you notice about both sides? Both sides are already instantly going down. So you'd be like, hey, I know the left and right sides are both going down. I instantly know the answers. I'm done. You can go look at a picture of a graph if you need to. Like if you need to go to a graphing calculator or Desmos. Okay, the graphing calculator is in front of me. You'd probably go to Desmos. And you want to look at a picture of that graph. And as I bring it up, so I just graphed that function, and there it is. Hey, is it a U-shape upside down? It is. But I didn't need time to do this because I know according to the degree, it's a degree of 2, it's a U-shape. If this number's negative out front, it's going to flip it over. Okay? So that means it's instantly going down on both sides. Or how else do we say down? Negative infinity. Or you could say it's falling. I think in Alex it'll use words. Whatever, just understand the difference. Okay? Now, if you know those hints, then it makes it real easy. Okay? And what do I mean by hints? If you know everything according to the leading term, okay? If it's a x squared problem, if it's an x to the 4th problem, if it's x to the 6th, x squared has 2 sides, 1, 2. X to the 4th has 1, 2, 3, 4. X to the 6th has 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. If you notice that, hey, what is x squared, x to the 4th, and x to the 6th? What do you notice about their end behaviors? They're the same on both sides. So when you also know 2, 4, and 6 are even numbers. So if I graph x to the 8th, I guarantee you they'll both be going 1, 2, 3, 4, 5, 6, 7, 8. Look, they're both going the same on both sides. So when it's an even number, when your degree is even, and this number out front is positive, whether it's an 8, a 1, a positive 1 out front, whatever it may be, both sides will be going up. If it's a negative number out front, all that does is it takes and flips your graph over. Okay? So x squared would be flipped over. X to the 4th, 1, 2, 3, 4. It's the same graph, it's just flipped over. So even functions, no matter what type it is, 1, 2, 3, 4, 5, 6, have the same end behavior no matter what their degree is. So that's what this table is saying. When it's a positive leading coefficient and an even degree, like 1x squared, it'll look like this. It'll be the same on both sides. The left and the right side are both going where? When it's positive and even, positive 1, even degree, x squared, both sides, the left and the right side, are going up. I'll say infinity. What happens when it's a negative and an even degree? Well, what did that do to your U-shape? It flipped it over. But Thrasher, what if it's an x to the 20th? It'll be the same thing. the left and the right sides, instead of going up, will go down. And we say that goes to negative infinity. What if it's an odd degree? So what if it's something that's a positive leading coefficient with odd degree? So what if it's a positive 1 x to the third? 1, 2, 3. If you notice, when they're even, both are the same. What happens when it's an odd degree? They'll be different. That's what odd means, is they're different. They're different on both sides. If it's negative x to the third, it'll start doing this first. Down, up, down. Okay? So if you know what degree it is, and this works for x to the fourth, this works for x to the fifth, this works for x to the sixth, x to the eighth. If you know what degree it is, you instantly know the answer if you got it going in the right direction. You can come back to this chart if you want to, but you know that the left side, over here, what's the left side doing? It's going down, and you know the right side, what's the right side doing? The right side's going up. So when it's a positive number out front, an odd degree, we know the left side is down and the right side is up. So instantly, once you want to know one side, you know the other. If you can't remember this, go to Desmos and graph it. But this is a little shortcut that gives you Blue's Clues to kind of help you with that. So what does the left side do here? The left side goes, in this case, up, and the right side goes down. When they're of odd degree, they are different on both sides. When they are of even degree, notice they're the same. Okay, notice even degrees are the same on both sides. Odd degrees are different on both sides. So when I look at a function without counting sides, I instantly know what it is. So like x to the x to the 7th. Number 7, hey, both sides are going down. Could you classify that? Oh yeah, both sides are going down. I may not know the degree, which I can show you how to find the degree. But what I do know is I know this guy's an even degree. Because when both sides are the same, it's even. When they're both going down, left and right both go, oh, that's a negative leading coefficient. Okay, and I just know that from my chart. Now, could you figure out the degree? I sure can. 1, 2, 3, 4. This is a 4th degree polynomial because it has 4 sides. Okay, at least. Now, it could be a little bit more depending, but we'll get into that stuff later. Okay, number 8. What do I know about 8? Ooh, they're different. So when they're different, I know this is an odd degree. And when the left side goes down, okay, let's see, the left side goes down. Ah, it has a positive leading coefficient. If you don't believe me, you can stick with Desmos. You can stay on it. If you're one of those people that don't believe in science, that's okay too. Okay, you can go look at it for yourself because that's what some people need, but that's how it works. Okay, all right.